You are standing in the middle of a brightly lit, sterile cleaning aisle. You are surrounded by hundreds of colorful plastic spray bottles. Each bottle claims to kill 99.9% of bacteria to keep your modern home completely safe from microscopic threats. You reach out your hand and pick up a heavy-duty bottle of toilet cleaner. Have you ever actually read the warning label on the back? Your eyes lock onto a warning symbol showing a skeleton hand dissolving in a drop of acid. The label warns that the liquid inside is highly corrosive and can cause permanent eye damage. You feel a sudden surge of modern anxiety. You carefully put the bottle back on the shelf. You rub your palms on your pants to find some peace of mind. You treat these everyday household chemicals with the absolute highest level of fear and caution. You wear thick yellow rubber gloves just to scrub your shower. You open every window in your house to make sure you do not breathe in the fumes. You believe that you are a highly advanced, rational, and cautious citizen of the scientific 21st century. But now, take a deep breath. Let your mind drift away from this comfortable, air-conditioned reality. Let us travel back 60,000 years into the deep, wild, and incredibly dangerous prehistoric past. Imagine standing completely barefoot on a vast, windswept savanna in southern Africa under a burning orange sky. Your skin is covered in a thick layer of dust, sweat, and ash from last night's campfire. Your hair is a messy, tangled nest of brown curls, and your only clothing is a simple, coarse piece of dried antelope skin wrapped around your waist. You do not have a chemical safety manual. You do not have rubber gloves. You do not have a poison control hotline to call. In your hand, you are not holding a pressurized spray bottle of synthetic chemicals. Instead, you are holding a tiny piece of chipped quartz stone, no larger than your fingernail, mounted onto the tip of a thin reed. This is your entire hunting weapon. And right in front of you, standing in the middle of a thorny acacia grove, is a massive adult male eland. This is an absolute unit of a beast, weighing over 900 kilograms, with long, spiraling horns and thick, dense muscles that could easily crush your entire chest into a pulp with a single defensive kick. Your stomach is growling fiercely, reminding you that your family has not eaten a real meal in 4 days. If you try to fight this giant antelope with your raw physical strength, you will be stomped into the dirt before you can even take a step. If you try to throw a regular, unpoisoned, stone-tipped spear at its massive shoulder, the thick, leathery hide of the animal will barely feel the scratch. The eland will simply snort, run away at 40 kilometers per hour, and leave you to starve to death in the dust. How do you solve this impossible physical equation? How does a fragile, hairless primate, with a weapon that looks like a toothpick, bring down a 900-kilogram monster? The secret is that you do not fight with your muscles. You do not even fight with your stone. Instead, you fight with nature's darkest, most brilliant chemistry. To understand how your ancestors pulled off this incredible chemical magic trick, we must first look at the real, hard archaeological evidence left behind in the dirt. For a long time, historians believed that prehistoric humans were just primitive cavemen who ran around waving wooden clubs. But in the early 21st century, a team of pioneering researchers completely shattered this outdated view. Led by Professor Sven Isaksson of Stockholm University and Professor Marlies Lombard of the University of Johannesburg, scientists began analyzing ancient hunting weapons excavated from a famous archaeological site known as the Umlatuzana rock shelter in South Africa. They focused their research on 5 tiny 60,000-year-old quartz arrowheads. Using a highly advanced scientific method called gas chromatography mass spectrometry, which is a laboratory technique used to identify chemical substances down to the molecular level, they discovered something truly shattering. Preserved in the microscopic cracks of the ancient quartz stone were the distinct molecular signatures of bufandrine and epibufenicine. These are highly toxic, neurotoxic alkaloid compounds that do not occur naturally on rocks or dirt. They are found in only one specific place in the African savanna, inside the bulb of a local plant called Buffon distica, which is commonly known as the poison bulb or gift ball. This means that tens of thousands of years before the pyramids, before the invention of metal, and before anyone ever wrote down a single word, your ancestors were already practicing highly advanced botanical chemistry. They were intentionally processing lethal plant toxins to turn their fragile, tiny weapons into deadly chemical delivery systems. How did ancient humans acquire such a deep, dangerous understanding of plant toxicology. The discovery of this hidden chemical power was a long, painful process of trial and error, written in tragedy and survival. Imagine a prehistoric gatherer walking through the savanna, searching for edible roots to feed the tribe. They spot a large, layered bulb that looks exactly like a giant, juicy onion growing in the dry soil. They dig it up and decide to take a bite. Within minutes, their mouth begins to feel completely numb. Their vision becomes blurry spinning and wildly distorted. Their chest tightens as the toxic alkaloids begin to paralyze their respiratory system, and they fall to the ground in a state of violent hallucinations, nausea, and panic. If that gatherer is lucky enough to survive the poisoning, they do not just forget about the plant. They share the knowledge. The tribe realizes that this bulb contains an invisible, silent, and incredibly powerful force that can paralyze a living body from the inside out. And then someone makes an incredible, revolutionary cognitive leap. They ask themselves, what if we could take this invisible chemical force out of the plant, put it on our tiny stone points, and let the chemicals do the dangerous work of hunting for us? This was the birth of chemical warfare. To turn this brilliant idea into a working weapon, you had to become a master of prehistoric chemical engineering. You could not just rub a raw bulb on your arrow and go hunting. The raw sap of the poison bulb is highly volatile and too watery. It would instantly wash off the moment your arrow brushed against the wet grass of the savanna. You had to concentrate the active toxins. You would sit on the dirt floor of your cave, carefully peeling away the papery outer layers of the Bufon distica bulb, making sure not to get the toxic juice into any cuts on your hands. You would crush the inner flesh of the bulb using a smooth river stone, releasing a thick, milky, and extremely bitter sap. To make it sticky and durable, you had to cook it. You would place the crushed pulp into a hollowed-out stone or a simple clay container and gently heat it over the warm embers of your campfire. You had to watch the mixture obsessively, ensuring the temperature was just right so you did not destroy the active chemical compounds with too much heat. As the water evaporated, the runny sap transformed into a thick, dark brown and highly concentrated paste. To make sure this toxic glue stayed bonded to your quartz arrowheads during a long hunt, you mixed it with a natural adhesive, such as sticky acacia tree resin or beeswax. Archaeologists have actually found the molecular remains of this exact adhesive mixture, preserved on ancient weapons at the famous Sibudu Cave in South Africa. Using a small wooden stick as an applicator, you carefully smeared this lethal paste onto the neck of your quartz arrowhead, leaving the very tip clean so it could still pierce the skin. This was a high-stakes, extremely dangerous chemical laboratory. One slip of your finger, one tiny accidental cut, and the very poison you were preparing to hunt with would enter your own bloodstream, paralyzing your lungs and killing you in the dirt before your tribe could even react. Why would you risk your life working with such a lethal substance? Because you knew that this sticky brown paste was the ultimate equalizer in the struggle for survival. Now let us reconstruct the actual hunt using this chemical masterpiece. You are creeping through the tall, dry grass of the savanna, keeping your body low to the ground to avoid the sharp eyes of the herd. You spot a massive male eland grazing near a dry riverbed. You are holding a small, lightweight bow made of a springy branch and a string crafted from animal sinew. Your arrows are incredibly light, made of thin, hollow reeds. If you were relying on raw physical power, these tiny arrows would be completely useless against a 900-kilogram animal. But your arrowheads are coated in the concentrated, dark brown paste of the poison bulb. You draw back the sinew string, taking a deep breath to steady your hands. You aim for the patch of thin skin just behind the animal's front leg, where the blood vessels are closest to the surface. You release the string. The arrow flies through the air and strikes the eland with a soft thud, piercing its thick hide by just a few centimeters before the shaft snaps off. The startled eland leaps forward, kicks its massive legs, and sprints away at full speed, disappearing over the horizon within seconds. If you were a Neanderthal hunter, you would be devastated knowing that your prey has escaped, and you must now track a fast, angry animal for days. But as a sapiens hunter, you do not panic. You calmly sit down in the shade of an acacia tree, take a sip of water from your ostrich eggshell container, and eat a handful of wild berries. You are completely relaxed because you know that the real hunt has only just begun. The arrow was just the syringe. The real hunter is the chemistry now coursing through the eland's veins. How could a tiny scratch kill such a massive beast? As the eland runs, its heart beats faster and faster, pumping blood through its massive body to escape the perceived danger. But this physical exertion is actually the animal's worst enemy. The increased circulation rapidly spreads the toxic alkaloids throughout its entire nervous system. The bupendrine begins to bind to the animal's neurological receptors, blocking the vital electrical signals between its brain and its muscles. For the first hour of its flight, the eland feels perfectly fine running kilometers away into the safety of the plains. But slowly, the silent chemistry begins to take over. The animal's heavy legs start to feel weak and unresponsive. Its coordination falters, causing it to stumble over small rocks and sandy ridges. Its vision becomes highly distorted and blurry, making it impossible to navigate the terrain. Finally, the toxins begin to paralyze its respiratory muscles, turning every breath into a desperate, agonizing struggle for oxygen. You rise from the shade of your tree and begin to track the eland at a comfortable, steady walking pace. You do not need to run. You do not need to risk your life in a dangerous, high-speed chase. You simply follow the animal's clear, wobbly tracks in the dirt, knowing that the chemistry is doing all the heavy lifting for you. When you finally catch up to the eland several hours later, the massive 900-kilogram beast is standing completely still under the hot sun, its head hanging low, totally paralyzed, and unable to lift a leg to kick you. You walk up to the quiet animal and end its life safely and humanely, thanking the silent power of the poison bulb for keeping your tribe alive for another week. This was persistence hunting, combined with advanced chemical warfare. This incredible mastery of chemical warfare was not just limited to one single plant or one single region. As your ancestors migrated across different continents, they encountered completely new environments with unique botanical challenges, and they had to continuously adapt their chemical recipes to survive. Let us look at the amazing discoveries made at the Kruger Cave in South Africa, where archaeologists unearthed a 7,000-year-old bovid femur bone. This bone was not just a relic of an ancient meal. It had been carefully hollowed out to serve as a primitive chemical container and quiver. Inside the marrow cavity, researchers discovered several bone arrowheads still coated in a dark, mysterious chemical residue. When they analyzed this ancient substance, they found something mind-blowing. The residue contained both digitoxin and strophanthin. These are highly potent cardiac glycosides, which are organic compounds that directly affect the heart rate. What made this discovery so shocking was that these two chemical compounds do not occur naturally in the same plant species. To create this specific recipe, the ancient hunters had to collect multiple different toxic plants, extract their specific chemical compounds, and combine them into a single, highly advanced, multi-taxa chemical cocktail. They were operating like prehistoric pharmacists, developing complex, multi-ingredient chemical formulas to maximize the lethality of their weapons. Why would they go to such extreme lengths to mix different poisons? This mastery of toxicology was a global phenomenon that developed independently across every continent your ancestors settled. In the freezing forests of northern Asia and Siberia, Paleolithic hunters discovered the lethal properties of monkshood, a beautiful purple flowering plant scientifically known as aconitum. This plant contains aconitin, one of the most deadly neurotoxins in the natural world. A single drop of this poison can cause immediate heart failure in large mammals. Ancient hunters used this potent toxin to bring down massive cave bears and Siberian ibex, turning the beautiful mountain flowers into silent killers. Meanwhile, in the dense, humid rainforests of Southeast Asia, hunters developed arrow poisons from the sap of the upas tree, scientifically named Antiaris toxicaria. Local legends about this tree warn that if the poison enters your bloodstream, you will take 7 steps up, 8 steps down, and on the 9th step, your life will end. These diverse global traditions prove that our ancestors possessed an incredibly deep, sophisticated understanding of their local ecosystems. They did not just live in nature, they read it like a complex chemical instruction manual. How did they map out this invisible library of death and survival? When we mirror this ancient chemical reality onto your frantic modern life, the contrast is truly mind-blowing. Today we live in a world where we try to isolate ourselves from all natural toxins. wrapping ourselves in sterile, synthetic environments. We buy organic foods, use eco-friendly cleaners, and panic when we see a warning label on a plastic bottle. Yet the entire foundation of modern global medicine is built on the exact same evolutionary chemistry developed by your prehistoric ancestors. Many of our most powerful modern pharmaceuticals are derived directly from the very same toxic plants used on ancient arrowheads. We use cardiac glycosides, like digitalis, extracted from the poisonous foxglove plant, to regulate heart failure in millions of patients worldwide. We use plant-derived alkaloids to fight cancer cells, manage severe pain, and perform complex surgeries. Modern medicine is not a completely new invention. It is simply the highly refined, commercialized legacy of the ancient hunter-gatherers who sat around campfires 50,000 years ago, crushing toxic bulbs with river stones to save their families from starvation. Ultimately, your long supermarket visit ends, and you step out of the automatic sliding glass doors into the warm evening air. You walk toward your car, carrying your bag of modern groceries and household cleaners, and look up at the sky. You look at the distant trees rustling in the wind, and you feel a sudden, profound connection to the deep past. You realize that your modern intelligence, your ability to plan for the future, and your advanced technology are not separate from nature. They are the beautiful, unbroken inheritance of a species that survived by learning to understand and cooperate with the natural chemistry of the earth. And as you drive home through the busy city traffic, unpack your sterile, modern kitchen and sit down to enjoy a safe, abundant meal with your family, you can rest easy, knowing that the ancient spirit of the human tribe, the clever, survival-focused chemistry of your ancestors, is still flowing through your veins, protecting you and guiding you through every single challenge of the modern world.